Okay, so let's look at this here. So we never want to multiply out if there's huge numbers like to the fourth power, never going to have you multiply that out. So we want to let u equal the inside function. So the inside function is 3 plus 4x squared. So if we take the derivative, du over dx is 8x. Again, we're going to always multiply by that dx. So we get to here. All right, so let me write down the problem again, and I'm just going to write it in a different order so we can see how we're going to substitute. So I have this x dx. Okay, so this is all x's, and I want to rewrite it with all u's. So I can put the u in here, so I get u to the fourth power. So I need to take out x dx and get u's in. So here I see x dx here. So what I'm going to do is I'm going to multiply both sides by 1/8. So I can see that I can take out x dx and put in 1/8 du. 1/8 du. So I'm always going to take the time to pull the numbers on the outside. And so then I can see this is a nice easy integral. Increase the exponent, divide it by that number. So I get 1 over 40 u to the fifth plus c, and put the x's back in to finish it off. 3 plus 4x squared to the fifth plus c. All right, so lots of things with radicals coming up here. Okay, so again, I'm always going to let u equal the inside function. So the inside function is 3 plus 4x. So du is 3 dx. So again, I'm just going to take the time to rewrite this. So I see I have 1 over the square root of 3x plus 4, and then the dx can be multiplied to the side. So I want to have all x's and then all u's. You don't want to have different letters in the same equation. So this is 1 over the square root of u. So I need to substitute in for dx. So here's dx. So if I multiply both sides by 1/3, I get dx is equal to 1/3 du. All right, so I'm going to take the time to pull the 1/3 on the outside, and then I'm going to rewrite this as u to the negative 1/2. Then I'm going to be ready to take the antiderivative. So that's u to the 1/2 over 1/2 plus c. So I get 2/3. And then it's u to the 1/2 power. So I'm going to put the x's back in for the u plus c. All right, so here I've got, again, I'm going to let u equal the inside of the radical. So du is 2x dx. All right, so I'm going to take the time to rewrite this. Sometimes it helps to see what you've got. So I've got 4x dx. Okay, so this here can be rewritten as the square root of u, because that's my u in there. So here I have 4x dx. So we have options of what we can do with that number. So what I could do is I could pull that number 4 on the outside, and then think about just substituting in. So I've got the 4 taken care of. What can I substitute in for x dx? So x dx is here, so I could do 1/2 du is equal to x dx. And so then I can put 1/2 du in. And so pulling all the numbers on the outside, I'd get 2. Square root of u, and I'm just going to rewrite it as u to the 1/2. And then I'm ready to take the antiderivative. So I would get u to the 3/2 over 3/2 plus c. So that's 4 over 3. And then I would have the 9 plus x squared all to the 3/2 plus c. So there's different options of what I could have done here. So here, what I could have done once I got to the du is equal to 2x dx. Let's put the big or over here. I could have multiplied both sides of this by 2. So if I said 2 du is 4x dx, then this turns into square root of u, and 4x dx gets taken out, and 2 du gets put in. Oh my goodness, isn't that the same thing as what I had over there? 2 du, right? 1/2 u to the 1/2 du. So there's the same in the end, right? So you have choices of how you want to substitute it in. It will give the exact same answer. All right, let's look at this one. Here I have u is equal to x cubed plus 4. So du is 3x squared dx. Remember, the derivative of 4 is 0. So I'm going to take the time again to rewrite this. X cubed plus 4 and then times x squared dx. So I can see them as separate. So x squared dx has to be substituted for, there it is right there. So 1/3 du is x squared dx. So I have 1 over, and I'm going to start by rewriting this as the exponent that it is, right? Cube root is 1/3 power, and x squared dx gets replaced with a 1/3 du. So I'm going to pull that 1/3 outside, and I have to rewrite this u in the numerator, so I get negative 1/3 du. So now I'm going to add 1 to the exponent, so I get u to the 2/3 over 2/3, or times 3/2. So I get 1/2 x cubed plus 4, which was the u, to the 2/3 power plus c.